Hi folks, we're going to take a look at the function on page 176, number 19, part 1. We're not going to answer the actual question. I just want to find some of the basic characteristics of this function. Okay, so step number 1 is to simplify to see if there's any common factors in numerator and denominator that'll help us reduce this expression. So here the top is easily factorable, so this looks like it's going to be x minus 4x plus 1 over x minus 2. Okay, so no common factors, meaning there isn't going to be any simplifying. So let's start by stating our domain. So the only x value that causes the problem is what makes the denominator 0. So our domain is, we could say, is all real numbers except the number 2. Or of course I can also do this in set notation, which would be x in R such that x is not equal to 2. Okay, so two different ways of doing it. Could even do it in interval notation, that's fine. So now I start on the list of my basic characteristics, and let's start with x-intercepts. Okay, x-intercepts of rational functions are found where the numerator of the simplified function is equal to 0. So that's going to be x equals 4 and x equals negative 1. Okay, next we'll go to our vertical asymptotes. Okay, vertical asymptotes occur when the simplified function is 0 in the denominator. So here our vertical asymptote is x equals 2. And I have to specifically write x equals 2 because it's the equation of a line. Now we'll go to our end behavior. Okay, and we notice that this function, because the degree of the numerator is larger than the degree of the denominator, is going to approach either positive or negative infinity. But we know that it's going to do so in a very particular way. In fact, because the numerator is 1 bigger in terms of degree than the denominator, we know we're going to have a linear oblique asymptote. And the way we determine that linear oblique asymptote is to divide these two polynomials. Now in this case here, I'm dividing by a linear polynomial, so I can use synthetic division. Obviously, if I was dividing by a quadratic or a cubic, I'd have to use long division. Okay, so let's go ahead and do the synthetic division. So our coefficients are 1, negative 3, negative 4, and we're dividing by x minus 2, so we'll use 2 here. So 1 times 2 is 2, negative 3 plus 2 is negative 1, negative 2 here, negative 4 plus negative 2, negative 6. Now this is actually not the important part, because what I'm interested in is the quotient. It's the quotient that's going to give me my end behavior. All right, so here we have a linear oblique asymptote of y equals, and of course this is just going to give us the coefficients of our linear function. So y equals x minus 1. Okay, now once we have our linear oblique asymptote, we can actually determine whether it's going to positive or negative infinity. Well, here, this, as x grows larger, this goes to positive infinity. Okay, whereas as x grows smaller, this goes to negative infinity. So that helps us also determine exactly the end behavior of this function. But it's enough, it suffices to say that it has this linear oblique asymptote, meaning over time, whether on the extreme right of the function or the extreme left of the function, it's going to be approaching this line, y equals x minus 1. Okay, and the next thing we're going to do is put all this stuff together to draw the graph itself. Okay, so that's it for this one.